Good morning, welcome to new lecture. Today I will solve several examples and we will look at the influence line for trusses. Assume we have this truss. Support here, it is hinge support. H, B, A, J, C, I, C. Even I can do like this. A, B, C, D, E, F, G, H, I, J, K, L. Okay, we want to draw influence line for this truss for member JK, which means this member. And pay attention, moving load is traveling in bottom chord here along this. So influence line for member JK, what we will do, there are two methods. One, you will put unit load at point A, then point B, then point C, then point D, E, F, G. And at each point you will find internal force in member JK and you will attach those points together. That is one way. Another way, using Muller-Breslau method, you will remove this member. You will apply internal axial force in this direction and you will draw the deformed shape of structure. If you apply force in this direction, this piece and this piece, both they will rotate respect to the D, G, A. So this point D will move down and then this piece will rotate respect to the G and will remain a straight line. And this part will rotate respect to A and it is a straight line. The height here is height. If this is A and this is B, because it is rotating respect to the D, from D to the A, I assume it is A, from D to the G, I assume it is B, that height will be A, B divided by entire length L times 1 over H. H it is height of the truss. And these panels, each of them, they are, let's see, 1, 2, 3, 4, 5, 6. Each one it is 3 feet, 3 feet, 3 feet, 3 feet. And this is 3 feet as well. So A will be from here to here 9 times B, again 9, divided by L, it will be 18 times 1 over 3. So if I calculate this, that height will be 9 times 9 divided by 18 times 1 over 3. Answer will be 1.5. So this height will be 1.5 and this will be negative. Because if load moves here from A to the G, the force we will have in JK member always it is a compressive force and that member JK is under compression. Let's draw influence line for member DE, this member. For member DE, again, you can put unit load at each joint A, B, C, D, E, F, G, and each time you will find internal force at member D. For example, you will put unit load at point B, you will find internal force in member DE, then the answer you will show as a height here. You will put unit load at point C, you will find internal force at member DE, then the answer you will show as a height under joint C, and so on, and then you will connect those points. That is one way. Another way, using Muller-Bress law, you will remove that member, you will apply this force. If you apply that force, the joint K will move up, and other parts, this part and this part, they will remain straight, and this part will rotate respect to the G, this part will rotate respect to the A. So this will be influence line. And here, because it moves up positive, again now this will be A, this will be B. So this height will be 12 times 6 divided by 18 times 1 over 3 A, B over L times 1 over H. H is height of truss. So answer for that, you can find it. That will be influence line for member DE. Let's draw influence line for member DK. Influence line for member DK. DK. You will remove this member, you will apply force in this direction instead of member DK. The form shape of structure, the point D will move up, point E will move down. This is point D, this is point E. Then you will attach using straight lines like this, positive, negative, and from here to here will be A, from here to here will be B. This height will be A over L times 1 over cosine alpha. Cosine alpha, it is the angle of this inclined member with vertical direction. That is cosine alpha. So this height will be B over L times 1 over cosine alpha. If you calculate this, this will be square root of 2 over 2, and this will be equal to negative, because this is negative, the magnitude will be 1 over 3 times the square root of 2. So let's look at the next example. Next one will be this truss. A, B, C, D, E, F. This height it is 1.5 meter. Each part here it is 2 meter. We want to draw influence line for member EF, this member. So you will remove this member. Again, load moves in bottom chord. You will remove this member. You will apply force in this direction. So point B will move down, and then you will attach using straight lines. Here, this height will be 2 times 4 divided by 6 times 1 over 1.5. So again I'm writing here 2 times 4 divided by 6 times 1 over 1.5 will be 0.888. So I can remove this. I can write this is negative and the height will be 0.888. Influence line for member BC, this member. For that member, again, you will remove member BC. You will apply load in this direction. In that case, point F will move up, or point C I can say, move up, and this will be A, this will be the location of point C, this will be location of point D. So the influence line for member BC, positive, again this will be 0.88, you can calculate yourself. Let's draw influence line for member BF. For member BF, you will remove member BF, you will apply force in the tension direction, in that direction. Point C will move down, point B will move up. You will attach using straight lines. So this will be 2 divided by 6 times 1 over cosine alpha, that will be 1 divided by 1.5 divided by 2.5. From there that will be equal to 5 divided by 9. Positive, negative. Influence line for member BF. Let's look at the next example. we have this truss. Height for this truss, it is 6 meters, and each of these is 5 meters. We want rope in close line for member GD, this member. So what we will do, again, load moves in bottom core. You will remove this. You will apply unit load in this direction. So point D will move up and point C will move down. So you can find this. It will be equal to 5 divided by 20 times 1 over cosine alpha. The alpha here, it is this angle. That is alpha, or this angle. It is alpha. So if you calculate that, you will get this height. It is equal to 0.325. From similar triangle, you can find this one will be 0.65. Okay, let's look at the next example. Should be A, B, C, D, E, F, G, H. Height will be 8 feet. 6 feet, 6 feet, 6 feet, and this is again 6 feet. Here, again unit load moves along bottom chord, so we want to draw in close line for this. For member CD first. Member CD, you will remove this member and and you apply force in this direction. In that case, you will see this point will move up, so point C will move up, and the deformed shape of structure will be this kind of deformation. This will be positive, this will be negative. 6 times 12 divided by 18, that will be 6 times 12 divided by 18 times 1 over 8, that will be 0.56 times 12 divided by 18 times 1 over 8. That will be, this is 3, this is 4, 4 divided by 8 will be 0.5. So that is influence line for member CD. Let's draw influence line for member GH. This member. Influence line for member GH. You will remove the member GH. You will apply load in this direction. So point D, in that case, will move down. And this will rotate like that. So this is negative, this is positive. Again, if you calculate, this height will be 0.5. Influence line for member GD. Let's do that. GD is this member, diagonal member. Remove that member, apply force in this direction. So point D will move up, point C will move down, and then the rest it is easy to figure out. Positive, negative, this height will be 6 over 18 times 1 over cosine alpha. Again, this is your alpha angle. If you calculate that, it will be 0.41. From similar triangle, you can find this one as well. Let's draw influence line for member GC. For member GC, this member, cut this member, apply load like this. Because traveling load moves from A to E, bottom chord, so point C will move up. Remaining part, there is no movement, so it will be something like this. And this will be positive, only one side it moves up, so this will be unit 1. And it is easy to figure out. If you cannot visualize that, you can do something else. you want to draw influence line for member DC. Put load at point A, find this member, internal force, it will be 0. Put here, find that, it will be 0. Put here, for example, force P, or 1, the internal force here it will be 1. Put at D, it will be 0. Put at E, it will be 0. So attached together, you will see, you will get this shape. Okay, I think it is enough for today. Thank you so much for watching this lecture. See you next session. Bye bye.